So our differentiation has made it possible to establish the best output for the firm and therefore the best way for the firm to use its resources. Given the complexities of demand and cost functions that were dependent upon output levels of more than one good, differentiation is easily the most practicable solution. Although we only had 2 products to consider, we've established the method. It's a simple thing to extend the analysis to any number of products. We simply need to know the appropriate cost and demand functions. But we haven't quite finished dealing with our current problem. We're still left with the need to find out how much profit is being made and also the price it should charge for each of its products. We've done our partial differentiation to find the optimal profit maximizing levels of output for our producer of more than one good. We now need to find out what's the best price to charge for each of these kinds of output, and also to discover how much profit per week we'll be making. Let's focus first of all upon the prices. For market 1, we had P1 equals AR1 equals 40 minus Q1 minus 3Q2. We now know that that is 40 minus 2.069 minus 3 times 7.82, because we've already solved for the optimum level of Q for each of the 2 kinds of output. And this comes out at 14.47 euros. So 14.47 euros is the optimum price to charge in market 1. We can easily find out the optimum price for market 2. P2, remember, equals AR2 equals 100 minus 2Q1 minus 4Q2. And we've worked out what Q is in each case. So that gives us 100 minus 2 times Q1 was 2.069 minus 4 times Q2 was 7.82, which comes out at 64.58 euros. So we're charging a much higher price in the market where good 2 is being produced than we're charging in the market where good 1 is being produced. Finally, we can work out the amount of profit that we're making. And we can do this because we can now say that profit equals, going back to what we said before, profit was 40Q1 minus Q1 squared minus 3Q2 times Q1 plus 100Q2 minus 2Q1 times Q2 minus 4Q2 squared minus 3Q1 squared plus 2Q1 times Q2 minus 2Q2 squared minus 80. And we worked out what Q1 and Q2 is. So we can simplify a little bit here and write that profit is 40Q1 minus 4Q1 squared plus 100Q2 minus 6Q2 squared minus 3Q2 times Q1 minus 80. Now substituting for Q1 and Q2 the answers that we already got earlier, and profit pi equals 82.76 minus 17.123 plus 782 minus 366.91 minus 48.538 minus 80, which sums to 352.189 euros per week. That's the profit that we'll make. So we began with a complex cost function and revenue functions because of the interdependency in production. But the use of partial differentiation has enabled us to determine the optimum output in each market, the optimum price to charge in each of the two markets, and also to establish the total amount of profit that the producer will be able to make.